Working in cybersecurity, I've seen AWS cloud admins create an IAM user, give it console access, and not assign it MFA. That may be for a variety of reasons, like they're testing out some type of workflow and MFA's, slowing down their process. But the fact is, you have an identity out there with console access and no MFA assigned. And security teams may not be actively monitoring this control failure. So in today's video, we're going to build a pipeline that automatically detects this gap, alerts the security team in real time, and builds evidence automatically. We're going to be doing this in our Shoreline Solutions environment, which is the fictional company we've been building out throughout this entire series. And at the end, we're going to take a minute to focus on communication and tying this work back to the business. So if you want to follow along, I'm going to include my GitHub in the description below. That's going to take you to the step-by-step guide, which has all the services and all the steps to complete this lab. Before we jump into it, let's take a quick look at how this workflow fits together, because if you're like me, it's much easier to understand the process and workflow when you can actually see it. So now I want you to think about this workflow in 4 different steps. The first step is to detect the issue. The second step is triggering the automation. The third is collecting the evidence. And the fourth is going to be the alert. Everything is going to start at the left side with AWS config. Now, config is going to continuously evaluate our environment against that MFA control. And if it finds that user, with console access that doesn't have MFA enabled, it's going to mark it as non-compliant. And that result is going to be sent immediately over to Security Hub, where it, becomes a centralized security finding. So between the two, we've detected the issue, but nothing has actually happened yet from an automation perspective. And that's where EventBridge and Lambda come in. You see, EventBridge detects that new Security Hub finding, and it's automatically going to invoke our Lambda function that we're going to build throughout this lab. So that Lambda function performs the automation for us. So it's going to write the evidence to S3 and send an alert through SNS, so the security team can be notified immediately when that user or control becomes non-compliant. So as we build this lab out, keep those 4 steps in your mind, right? Step 1 is detect the issue. Second is trigger the automation. Third, collect the evidence. And fourth, send the alert out. So here I'm going to go ahead and navigate over to Security Hub CSPM. And I just want to show you the finding and the specific control we're going to be automating, which is going to be that MFA on IAM users with console access. I'm just going to copy and paste the name right here. So that finding is here and active, and you can clearly see the workflow status. You can see the workflow status is new, and that's something our automation is going to be, leveraging or triggering off of. So we've confirmed the finding is there. Now we need somewhere for our alert to actually go, which is going to be SNS. So once you navigate over to SNS, we want to create a topic. And SNS doesn't do anything on its own. It's going to rely a lot on Lambda. And basically, it'll just drop a message every time it's going to find a non-compliant IAM user. So we're going to create a standard SNS topic here. We're going to call it Shoreline MFA Alerts. And then you want to subscribe your email address to it. And AWS is going to just send you a confirmation email. And you want to go ahead and click that link to activate it, so you'll actually get notified once this automation is set up. And once that's done, we have our notification channel ready. Now we just need to wire up the Lambda function to actually use it. So here we're going to be creating an IAM role, attaching a policy that's going to give it 3 specific permissions. It's going to be able to write evidence to S3. It's going to be able to publish alerts to SNS, and then also write its own logs to CloudWatch. And CloudWatch will be a separate topic, so I'm not going to go into too much detail on that. Now under IAM, you want to click on roles and then create role. And for the trusted entity type, leave it as AWS service, and use case, we want to choose Lambda. And then go ahead and hit next. Permissions policy, you can skip over this and hit next. And role name, go ahead and grab it out of the GitHub repo. And then go ahead and create the role. So now that we have the role created, we're going to be attaching that inline policy that gives it the 3 permissions I just mentioned. And this is going to be all in JSON format. You can copy this directly from the GitHub repo. And make sure to fill in your resource arns and suffix so it's pointing directly to the resources you're granting this role permission to. I'm going to skip ahead just to leave all my account information out of this, and then go ahead and click next. So we created the Lambda role, and the next step is step 4, which is to create the Lambda function. And to do this, we need to navigate over to Lambda and then click on create function. And for function name, I'm going to be using MFA finding handler. And for runtime, go ahead and choose Python 3.14. And we want to make sure we adjust the execution role. So we're not going to be creating a new one here. We're going to be using the role that we just built for step 3, which was the Shoreline MFA Lambda role. And that's what's going to give this function permissions to actually touch S3, SNS, and CloudWatch. And once you save that, go ahead and hit create function. Now that the function's created, we now need to add environment variables. And this is what makes the code reusable. You see, the logic in the code is going to stay generic, but the 2 variables that we're creating are what point at the bucket and the SNS topic. So you can click on configuration and then environment variables. Now you can add both the bucket name and SNS topic as the keys, and the value, you just want to add in your actual bucket name and SNS topic arn. And once you have those added, go ahead and click save. At this point, the function exists, it has the permissions to act, and it knows where to send its output. So for step 5, we're going to be adding the code which powers the automation for our Security Hub finding. So to add the code here, we need to stay in our Lambda function and then click on the code tab. And then whatever's in the code block, you can delete and then copy and paste the Lambda function from my GitHub repo right into this block. I want to take a minute here and discuss this function at a high level and focus on 4 things this function actually does. So the first thing this function does is it's going to ask, is this something I even care about? For example, Security Hub CSPM sends all kind of findings through here and not just the MFA ones. So the first thing this code actually does is check, is this the MFA control that I care about? And if not, I'm going to ignore everything else. And second, it's going to basically perform a gut check on the MFA control. So once it has that MFA control, it's going to check if it's live and if it's currently failing. And third, it's going to start to build that paper trail that we want. So for example, this function is going to grab key details that we need. So this is going to be like the user, which control is failing, which is going to be obviously the MFA control, the severity of it, and also give it a timestamp, package all that together, and output it into a clean JSON formatted file. So fourth, it's going to take that JSON file, store it in S3, and also give us an alert through SNS, which we'll receive through the email that we used to subscribe through SNS. From here, make sure to click deploy. And now that we understand how the function works, let's add some test data to see if it's working as intended. Go ahead and click on test, and then you can just call it test one. And then in the event JSON, go ahead and grab the test data that's in the GitHub. So this JSON right here is just a fake finding. It's built to look exactly like the real one from Security Hub CSPM. You'll notice I have the control, it's marked as failed, the workflow status is new and it's active. I also put a fake user here, and this hits every single check our code will hit in production. So once you test it, you'll see it's successful, and there's also evidence stored in S3. And then also go ahead and check your email, because you should receive the same evidence sent directly to your email. Now I'm going to navigate over to S3 and just look at that evidence so I can show you exactly how it outputs. So this will be in our audit logs and MFA evidence. Then go ahead and click on the timestamp. I have a few here, but I'm going to click on the most recent one. And you'll notice I have compliance status failed. I have the title of the control, which is the MFA one, and all the data that we want to show that we're monitoring for MFA compliance. So now that we confirmed our function's working, we now need to build the EventBridge, which is going to act as that trigger. So navigate over to EventBridge and think of EventBridge as the tripwire. So Security Hub CSPM findings come in, and the second it matches, it automatically triggers our Lambda function, removing the overall manual effort. So once you're in EventBridge, go ahead and hit rules and then create rule. I'm also going to give it a quick description just to remind us what this trigger actually does. Event bus, leave as default, and then click next. Event source, leave as AWS events, and then event pattern, you want to choose custom pattern, and that's where we're going to input our own JSON. I want to explain the JSON real quick here to give you a better understanding what this is looking for. So first, look at the source. What we're saying is only listen to events coming in from AWS Security Hub. That's the service name AWS uses internally, and specifically, this is Security Hub CSPM. Second is the detail type. So this is basically saying only care about findings that we just imported or findings that just recently got updated. In plain terms, anytime Security Hub CSPM creates a new finding or rechecks an existing one, this rule is going to catch it. So to put this event pattern together, we're just saying anytime Security Hub CSPM either creates or updates a finding, send it my way. EventBridge is not doing the filtering for the MFA control. That happens later inside the Lambda function itself. This rule here is just intentionally broad, and it's Lambda's job to narrow it down later on. So once that's filled out, you can hit next, and then leave the target as AWS service. And then for the target itself, we want to make sure we choose Lambda. For the target location, we want to make sure we actually choose our function, which is the MFA finding handler. And for execution role, you can just leave it as the default, which is the create a new role. And then go ahead and hit next. And then create rule. So we have our EventBridge rule created. And one thing I want to note is this is not on a timer itself. The second a real finding comes through, that's when it's going to immediately fire. Now that we've tested the workflow with some sample data, we now need to prove the whole work chain works end to end and not just Lambda by itself. So we have two options of doing that. The first way is to create an IAM user, give it console access, and then don't turn MFA on for this user. You see, AWS config will catch it, and Security Hub CSPM will eventually raise that finding, but this is going to take some time. So a much faster way to do that is to navigate into CSPM and change the workflow status of the MFA control. So I'm going to head into Security Hub CSPM and go to Findings. And I'm going to search for the MFA control finding and click on that. And then under workflow status, I'm going to change it to resolved and then hit set status and then immediately change it back to new. So give it a minute and you should then receive an email based off of the email that you put in for the SNS topic. So just like that, I received my email and it has the JSON output as expected. So that email right there proves our entire chain works end to end. So I'm receiving the email alert and the evidence is also going to be sitting in our S3 bucket. All right, so with the entire pipeline confirmed working end to end, let's take a step back here for a second because I want to talk through what we actually just built and why it actually matters. So today we built more than just an alerting workflow. We built a compliance process that's repeatable, scalable, and ultimately reducing risk. And I want to focus on, 3 different outcomes that tie back to the business. And the first one is going to be speed. This workflow immediately alerts the security team the moment this control fails. And second is going to be the consistency, because every finding is handled the exact same way it's marked as non-compliant. And third is the accountability, because we have a complete audit trail showing what failed, when it failed, and where that alert was sent out. So instead of relying on, manual processes or screenshots showing this control in place, we've automated all of that and then ultimately reduced, the chance of a missed identity risk. So to really summarize it into one sentence, we transformed a manual security control into a repeatable, scalable business process that reduces risk and helps our organization respond consistently every time. So thanks for sticking along, and I hope you got something valuable out of this lab, and I'll see you guys in the next one.